welcome to Teaching Mathematics. Today we're joined by Tamlin.
Hi, how are you?
I'm well, thank you. How are you?
I'm very well, thanks.
It's always good to have you.
Thank you.
Welcome back. And of course we have Dylan behind the buttons who will be controlling everything. Remember, he is watching out for your tweets as well as your Facebook comments and your chats on the chat box. If you don't know how to use the chat box, just scroll down just a little bit. You'll see on the Digital Classroom webinars page that there's a little box that says enter in your nickname. Put a nickname in, click log on, and start chatting there. If you're on Twitter, use the hashtag MEMaths. Or if you're on Facebook, go to Digital Classroom South Africa, find the post for today and start commenting on that. Dylan will be watching all three. If you chat to us during the show, you could win 110 Rand Vodacom airtime. So it's worth chatting to us. And plus, we're interesting.
Oh, absolutely. That would be the first reason, yes.
Very definitely. Now, Tamlin, you've been here before.
I have, yes.
But it has been a long time.
Yes.
Yes, so why don't you remind us, who are you and why are you here?
Well, I've been teaching maths for a very long time in a fairly kind of different context. I've, in the past, run an extra maths tuition centre where we taught pupils after school. And it was a very big centre and it was very dynamic. We had a lot of different age groups, lots of different schools, so it was always very interesting. And what was great about that is that I got the opportunity to learn good little ideas from lots of different schools and good ways of teaching and just nice methods. So I really felt like I really got a really good grounding and basis for a lot of my teaching methods from that. Quite a unique experience because not many people have the opportunity of having that.
Yes, you've touched on something quite valuable there, I think, and that is that change can allow for growth within yourself and your teaching methods.
Absolutely, yes. And you know, just networking with other teachers in different schools can give you just a perspective that you maybe didn't have on something before, a method that you maybe just weren't familiar with, or maybe a method that you weren't always comfortable with, maybe just hearing somebody else explain it actually will just clarify what maybe you were not so comfortable with, and then you have it, then you can use it in your own classroom. So
now, once again, you've touched on something else that's valuable, and that's the need to communicate, the need to network.
Absolutely.
Especially in our subject.
Yes, yes.
This is actually quite an interesting point because, as you know, we do the science webinars as well as these ones. And what I find with science teachers is that they generally are a lot more, and all us maths teachers out there don't want to hear this, but they generally seem to be more engaged and more excited about their subject matter, and as well as the students. And I could very well be wrong. Please send us your thoughts and comments.
I think I'm going to disagree with you over there if that's it.
But this is my thought as to why. It's because with maths, it's almost a forced subject. If you don't do maths, you do maths lit. So it's like you have to do maths because otherwise you're seen as stupid.
Yes.
So what you have as a maths teacher is a class of students in front of you who maybe aren't actually that interested in their subject. And it makes you feel horrible when you're teaching people who aren't engaged. Let me finish.
Yes.
I'll let you jump in. I'm like, yes, I know. Whereas science, you've got the ability to explore with different apparatus, and you can trigger different students' reactions and interests in the lessons. Maths, it's algebra, it's Euclidean geometry, it's statistics. There's no real opportunity for everyone to find something that they're really interested in. So it almost feels like you're alone. And that's where I was going.
Yeah. I think the nature of science, because of the practical elements of it, you know, you can play, and as Dylan said earlier, you can blow things up. And I think, you know, children find that exciting and it's enjoyable for them. You know, I can only speak for myself. I love teaching maths. I love teaching it because I love taking what my understanding of it, and if I understand something and just imparting that on the kids and getting to the point where I can see that they understand it. And by understanding it, they can find that actual value in it. You know, it's not just numbers or it's not just tables and graphs. There's actual value in it. And that's where I get excited about, is where they can actually get to the point where they can appreciate that. I don't think we're going to have we're not going to convert everybody to being mathematicians in the world.
No.
But, I think, the aim is if we can, come to the end of a year and the pupils can look back on what they've learned, and it's not just a blur of numbers that they've had put into their heads. If they genuinely can, add context to what they've done, if they can add practical value to what they've done, then I think we've done a good job.
But in terms of the communicating with each other, do you think we do that very often as maths teachers?
Probably no, not enough. I'm sure that there is so much that can be learned. I think often we tend to maybe keep very close to ourselves what our work and what we put together. But again, just from what I've experienced in the past, looking at different teachers' tests. If we even just shared our different tests, because what happens, and particularly in a school like where I am now. I'm one of 3 math teachers, so there's not very many of us to share. And you tend to have your own style and your own way of setting tests and exams. And it's you start worrying, is it just becoming a bit of a copy and paste, formats and things like that. So seeing other teachers' tests, the way they're questioning, things that they're seeing valuable in the syllabus and examining on, the way that they're doing it, all of those little things just add to a greater understanding and a greater ability of making the subject exciting.
Yes.
Yeah.
And exciting for yourself as a teacher.
Absolutely. Yeah,
yes.
Absolutely.
It's nothing worse than a bored maths teacher.
Oh, no. I can agree with that.
And it can become tempting to be bored in your class. It's algebra, like grade 8, grade 9, grade 10, 11, 12. Yeah. It's functions.
Yeah, absolutely. So, no, of course. And I think, you have to almost stimulate yourself as the teacher, looking for different resources and different ways of presenting the info, whether it be even through the use of the internet, using YouTube videos I guess the point is, as teachers, we're not stuck to just worksheets and textbooks.
Yes.
We actually have a lot out there that we actually are able to use if we just use a bit of imagination. I think people think that mathematicians are not imaginative, but
that's absolute rubbish.
But
really
absolutely
is.
no. I mean, there's so much out there that we can use, and it's out. We have to try and think out the box and use what we've all got thrown in the pot, and hopefully we can all teach the best that we can.
And not every lesson has to be over the moon exciting and amazing.
No. And in fact, honestly, what I have found over the years is that the children don't like that.
Yes.
They like to know that they've got solid grounding, that they've had, their good theoretical lessons where they've got the good hard theory. And then once they've got comfortable with what they're applying, then you can start getting interesting and, throwing a few exciting things in there. But you kind of want to keep that balance between giving them the hard facts, because they like that, they feel comfortable with that. They want to know that they've got the necessary knowledge.
Yes.
And then to start kind of changing their mindset that they actually can apply this, and they actually can find scenarios that would apply, and they could actually use this mathematical knowledge. So,
Yes. Well, I have taken us sufficiently off
this
topic, and we do need to move on.
Yes.
Now, as you know, I have been reading this book called Teach Like a Champion, and it has 49 actionable techniques that you can use in a classroom. I'm finding more and more that a lot of them are just common sense teaching ideas, and probably most of us are applying them. And this one is a perfect example. Mm-hmm. Number 22, cold call. It says, how can I adapt my decisions about which students I call on to help all my students pay better attention? And I think we do this automatically.
Yeah, it's quite a nice, it's a bit of a discipline tool sometimes, is when you're busy teaching something. An excellent way to pull back somebody who you can see is not paying attention is to suddenly say, John, what exactly was the answer to that question? And they look at you with big eyes and suddenly they don't know. It shouldn't really, I guess, be the only reason to do it.
But it does keep them on their toes.
It keeps them on their toes, yeah. And, just asking how to best make the decision on who to call on. I suppose you don't want to put your timid child under unnecessary pressure, and you want to encourage them to think out loud and to try. So I suppose, you just got to be careful with that as to who you call on. But then you also don't want to... Your loud extrovert, you don't want to only ever call on them because they're the ones who are willing to speak out. So, it's a case of just drawing out the ones who are quiet, but maybe by not throwing them with the most complicated question you can possibly throw at them, then they'll just cower and not want to answer at all.
Do you remember Who Wants to Be a Millionaire?
Yes.
I know it still shows on BBC. But that 50-50 call a friend and ask an audience.
Yes.
I think that's an excellent strategy. If you've called on someone who doesn't know the answer, to say, okay, well, choose
Call
your
a
option.
friend. Yeah.
You're going to call a friend, you want 50-50, or do you want to ask the audience?
Yeah, it's quite a good, it is actually a nice strategy.
And then they still have to answer the question themselves. So they still have to process, is this person giving the right answer?
Yeah, actually, I like that. That's great.
I'd forgotten about that, actually.
Yeah, that's excellent. I think I'm going to use that.
Yeah, I'm going to write it down.
Definitely.
Put it in the blog.
Yeah, but I think fact of the matter is they need to know that they can be called on at any point in the lesson to engage with you. And it doesn't have to be, they have to also, I guess, just put at ease to know that they don't have to be right. Just the fact that they're trying to answer is worth something, because they are engaging and they are trying. So
now it's going back, and then I promise you we're getting to statistics. Going back to that person who's daydreaming.
Yes.
I wouldn't necessarily call on them in that moment of daydream. What I'd probably do is say, okay, Dylan, stand up, you're swapping with Tamlin, and get them to do a physical action. Dylan, you can sit down now. And get them to actually physically move so that they're with you. And then in the next 3 questions, ask them one of those 3 questions.
Yeah. I guess, I would say that's absolutely fine. I wouldn't do it more than once in a lesson. It causes disruption, and they will think it's funny, and it takes them another 2 minutes to settle down.
That's true. Okay, so it's a poor...
You know what? We have all these different ways and means of keeping their attention. I suppose everyone develops their technique, and I just find that I think this comes from teaching and having had a very big class, and you have no option but to keep control of that class all the time.
Yes.
So to do something like that, instantly you
get tripped up or something.
You lose them. Yeah. So it's just strategies and techniques. I guess the classroom environment that you have will also allow for that kind of thing or not.
Very true. Okay. Yes. Let's move on to your 5-point teaching strategy.
Yes.
And you've got them over 2 slides today.
Yes.
They are very similar. You were here for
grade 10
statistics. And we spoke about this.
We did. The nature of statistics as it follows through from grade 10 through 11 and 12, there's definitely repetition there. And that's actually, to a point, the challenge in teaching this section is that, the kids don't look at it and think, oh, come on, we've done this already, so there definitely is repetition in the way, the content. There are new things that get added in obviously 11 and 12, but the fundamental concepts are the same.
Yes.
I guess the challenge is maybe to get them to just understand it a little bit more deeply, understand how to apply it a little bit better. But as I say,
you could almost apply the same teaching strategy.
Yeah.
Except it expands.
Yeah. I mean, it's sort of like in grade 10, we teach them what the mean is.
Yes.
In grade 11, we teach them how to consider the mean, in comparison to standard deviation, and looking at the mean and interpreting box and whisker diagrams. So now you're taking just the mean, but applying it in sort of more detailed concepts. Yeah.
Okay, so your first point says teach the statistical process of collection, representation, and interpretation of numerical data.
I just like this process because I think sometimes the children feel, especially as a teacher, I think it's difficult sometimes to kind of find a place to start with teaching stats. Is it a case of just throwing all these numbers at the kids and then kind of finding your way from there? To me, by kind of breaking it into these sections, it just gives me as a teacher clarity as to how I'm actually going to approach this. So obviously the collection, we don't necessarily do the collection of the data in class. It's the practicality of it is not very good. But they need to understand where this data comes from. That there are processes that carry on in order to actually collect all that data. And then from there, the representation. So you've got all of this data. Now you've actually got to put it into some kind of picture and form a diagram that you can actually start then interpreting information from it.
Yes.
So just breaking it into those categories, I think, just gives us as teachers just a more structured way of approaching the whole section.
Would you break those categories up for the learners and explain them individually?
I do. So when I teach it, I literally do say to them, right, there's 3 processes, there's 3 overall steps to this entire section. And then from there, say, right, obviously your representation. So once I've explained to them the different types of data that you get your grouped data and you have your discrete data and all of that.
They struggle with that. I don't know why, but they're just discrete and
they do, and it's
continuous.
And then but basically once they understand that there is actually just a difference between the two, then you can start talking about the representation of discrete data and group data is actually different. There's different ways of representing the 2 different types of data.
Maybe it makes sense to talk about the different ways to represent the data and the reasons for the different ways, and then introduce the terms discrete and continuous.
Yeah.
But of course, this is grade 10 and grade 9.
Yes. Okay. So at this point, essentially, so basically, in grade 11, as we stand, they now know what it is.
Let's hope. Yes,
we hope. I do think it's worth in grade 11 doing revision on it. I do think that it's worth not just assuming that because you also find maybe they've had a year. They're a year older. They've had a year on what they've learned before. They might just understand it a little bit better than what they did in grade 10. So I would say start off the whole section by clarifying and just going over again the whole concept of grouped and discrete data.
There have been studies on the maturity of brain versus the ability to do different operations.
I think there's a lot of truth in that.
Yeah. So really the older they get, they can just grasp
have that ability to just get their heads around that little bit better. Yeah. So absolutely. And what's nice about as the section really follows through from one grade to the next, we have the opportunity to go and reinforce the terminology and the concepts that we learned before. So, and hopefully, a little bit of maturity, they understand it a bit better.
Yes.
Yeah.
Okay, the next point says representation. Ensure learners understand that various graphs and charts are suitable for discrete, ungrouped data, and others are suitable for continuous group data.
Okay, so again, just saying, your bar graph versus your histogram. So you've got your pie chart, which is going to be your discrete data. You've got your frequency polygon, which is your group data. So just understanding that it's not a case of you can just use any graph for any data. There are differences, and there are certain graphs are applicable to different types of data. This is, again, something that I wouldn't spend too much time on in grade 11. They have learned it in grade 10. So, it's really, this is, as you know, in grade 11 terms, an introduction to the section again. You're just reinforcing the concepts and just making sure that what was learned before is understood, because it is important. If they have a shaky understanding of their grade 10 work, to try and build on that's going to be tricky. So just in making sure that their understanding is important.
Now, I'm trying to remember the last time I saw any exam paper that asked learners to represent data graphically. And I can't actually, especially in grade 11.
It can happen, you say that particularly things like histograms and frequency polygons, they do get asked. Maybe not very often, but it can come up. So I think it is important. And in grade 11, as we'll discuss later, the O-jive graphs, those are definitely ones that they probably invariably have to draw in the exam. So.
And O-jive is the word that's spelled O-give.
Yeah.
Yes.
O-jive, O-give, yeah.
He actually knows how to say it properly. Yeah. Okay, so the next point is, unless you want to say more?
No.
Okay. The next point says interpretation, measures of central tendency, mean, median, and mode.
So obviously the value of reinforcing this in grade 11 is that the concepts of mean, median, and mode, we take that further in grade 11 and we apply that to box and whisker diagrams and the interpretation. Although we do that in grade 10 as well, a little bit more complex interpretation of box and whisker diagrams.
Yes.
Again, just making sure that there's a solid understanding of each of those concepts. There's maybe no confusion between understanding what a median is and what a mode is. A median and a mean. All right. Just that there's a clear understanding of that, so that moving forward, the building of all those concepts is solid.
I do wonder if... okay, so let me start with this. The interpretation question usually tends to be about the numbers.
Yes.
Tell us which is the mean,
Yes.
what is the median. Interpretation in our exams aren't usually about interpreting the data to come to a conclusion.
Sometimes, particularly when we're looking at things like box and whiskers, they'll actually have to sort of in sentence form actually draw conclusions from the diagrams.
Okay.
So they have to discuss their conclusions as opposed to just giving numbers.
Yes.
So in grade 11 that starts to become part of the answering of these questions. Some of them do require a bit of a discussion of their solutions.
In terms of assessment, how many marks are usually allocated to those?
Not very many, to be honest. You'll have one question where you'll have a box and whisker, and you may say to them, discuss the findings, in which case they would have to, I suppose we'll talk about those later, but they'll have to discuss all the different, what would be the best interpretation of means versus medians, maximums versus minimums, symmetry, skews, all of those sorts of things.
Now I'm going through this questioning for a reason. This is the one section that's actually really easy to apply to real life, because you're taking all of your data from real life.
Yes.
And yet a failing on the part of me as a maths teacher is that I don't actually bring real life into the discussion. And my number one focus is to get my learners to get the best marks they can possibly get.
Yes.
So maybe it's not my failing, maybe it's the failing of the assessment.
True. I think the reason why we sort of tend to rely on the examples that we have and what have you is that, and I'll speak from experience here, when I've gone off onto the stats websites and I've tried to make questions up for myself, it's not the easiest thing difficult to do. It's quite tricky because you're trying to assess the learners, so you're trying to get a valuable answer out of them. So if you're trying to compare two different sets of data, you have to have something worth comparing.
Yes.
Which is not always easy to find just out there in the world. They are there, and they're certainly not impossible to find, but it's just tricky. So I think within the context of the classroom and the context of an exam, the point of assessing them is there's certain things that we want to know they can understand and interpret from a diagram. So that's why we kind of stick to, the context, the content that we have.
Yeah.
But the stats are everywhere. It's just depending on what you want to do with them.
And you can actually make quite a lot of money from stats.
Yes, absolutely.
And yet we don't, or I didn't, ever bring this up in class at all. I never emphasized the fact that this was an important skill. Yeah. And they should learn how to use it.
Yeah, absolutely. I mean, as an example of, discussing my husband who did his MBA, and he had his data that he gathered, and for his thesis he actually had to employ somebody from the university to run his stats on the data that he had gathered. That was practical data that he had gathered, and and he needed somebody who was familiar with the stats to actually run those stats. Yeah.
It's a fascinating skill to have. It's not a skill that I possess or have developed. This ability to analyze huge amounts of data.
Yeah. I think for what it's worth in the school context, we do keep the examples limited, but I think, if we at least are teaching them, as you said, those skills, we kind of, what's the word? We're kind of canning it, if you will, for what we want. We're kind of making it very obvious, but we want, at the end of the day, we want them to be able to spot those things as a basic skill. If they understand that, then, going forward, if they take stats further in university and what have you, they then will build on it from there.
And maybe that's okay.
Well, I would believe it is, because, unless our job at this level is to do that, is to sort of start setting those foundations for going further. So, yeah.
Good. Okay, the next point on the next slide says interpretation, measures of dispersion, and I always picture someone spitting when I say dispersion. But it's a really good example to use. So this is dispersion, it's like spitting. Where has your spit landed? And of course, it's range, quartiles into quartile range, and working with group data.
Yeah. So this gets introduced in grade 10, but I think this is definitely where we start expanding on in the grade 11 syllabus. Looking at how is the data spread around the median, and what is the comparison of that to the mean, and and then you can start taking some quite valuable information or interpretation from that data. So I think this is definitely now where we start stepping it up in grade 11 to interpret that kind of information.
Yes. And the next point says interpretation, the 5-number summary, box and whisker diagram.
Yeah, so we've got your, this again, they will definitely be asked in their exams to sketch box and whiskers, so they must always just remember to be familiar with the 5-number summary. Sketching the box and whiskers, I think, is the easy marks in terms of that particular section. I think the interpretation, when they're actually given the diagram and they have to sort of make some kind of comment on it, and even more so when they're given 2 or maybe 3 different box and whiskers together and making a comment on that, that's where in grade 11 they're going to just be pushed that little bit further. But again, knowing the basics of all of that, in terms of teaching it, I would definitely start by just doing a review of the 5-number summary, and then
they do know it from
again
before.
They do, and I would even in grade 12 just do a quick revision of it so that's that it's clear, and because it definitely will come up.
And we are going to talk about them in more detail just now, so we're skimming through this quickly.
Yeah, that's fine.
But don't worry, we're coming back. Okay, so shall we look at your 3 pressure points?
Yes.
Okay.
Okay, so in the grade 11 syllabus, sort of the new elements of the syllabus that get introduced are concepts such as cumulative frequency, which is one of the first ones we do. So the learners have their grouped data. They taught how to find the mean or the estimate mean of the group data. They're able to find within which of the class intervals the median would lie. But if they were actually asked to find an estimate of the median, this is where your cumulative frequency is going to become handy.
Okay.
Because this is now where you would be able to actually put up a cumulative frequency table, which we'll do an example of shortly, and then from there actually sketch what we call the ogive graph. And from that ogive graph is what we use to help us find the estimate median as well as the lower and the upper quartiles of grouped data.
Okay, your point says cumulative frequency, an effective way of representing group data. Ogive graphs are graphic representation of cumulative frequency.
Yeah.
How would you introduce this to your class?
Probably my best...
do you want to go to the next slide?
Yeah, it would be to do it with an example.
Okay, so we've got a slide up with an example on it, and this comes from the Mind Action Series Grade 11 textbook workbook.
Yeah, okay.
Yes.
So this is actually the book that we work on in class. So basically I would start by discussing the fact that we've got group data. So we've got all our class intervals, and this is nothing that they don't know. They've seen all of this. And they would have their column for frequency. And then we'd have a new column, and so the first 2 columns are familiar to them. Then we would have our cumulative frequency. So the word cumulative, you're gathering it as you're going. You accumulate your amounts as you go through the table. So starting with each of your intervals, you would start with, as it actually quite nicely sets it out over here. So your first one has a frequency of 0.
Okay.
Going to the next category or the next interval, you're taking what you had before, so we're gathering, keeping it along, plus the frequency of 11 from that class interval. Then moving it along, you're taking your total of 11, bringing it along, and you're adding the next frequency to it, and so on. So each step down accumulates the frequency as you're going. The total that you get to at the bottom, so that's 77, will be the frequency, the total frequency of your, will be the same as the frequency that you have in total. And so that's the column over there that we've filled in. And this is this 4th column over here has quite a nice description.
The 4th column is fantastic.
Because it actually explains what exactly is going on there. So basically saying that at the point of 30 years or less, we have a total of 25 people who are 30 years or less. And then at 40 years or less, it's now accumulated to 42 people and so on.
Yes.
So it's quite a nice explanation of actually what's happening.
They've done that
over there.
really, really nicely.
Yeah,
I think that's
yeah.
the best I've seen it set out. Well done, Mind, actually.
So it's actually a fantastic book. And okay, so then so I would definitely introduce it with that as a starting point.
Now the graph points is something they struggle with.
So it's really just a case of knowing what they have to use as their X and their Y coordinates. They need to understand that when they now have to take all this information and they need to put it onto your OGAV graph. And the way they're going to plot it is that basically the X and the Y coordinates, the X coordinate is always the upper boundary of your interval.
Yes.
And the Y coordinate is always the cumulative frequency.
Yes.
And if they understand that, then it really shouldn't be a problem.
Yeah.
So that's just a case of, I guess, a bit of theory that they need to be clear on.
Yeah. So if they can apply that, then it's...
Yeah, so it's just understanding that your X coordinate's the upper boundary of your class interval, and the Y is the cumulative frequency.
Now, when they're drawing this table up for the first time, do they really understand what they're doing? Or is it something that becomes apparent after they've found the median, usefulness
I think the usefulness of it, I think does become more apparent with the graph itself. I think at this point, making it clear with that particular explanation or whether you explain it to them just verbally, I think that's giving them a picture as to what they're doing. They're finding this total at a point, the cumulative total at a point. And then from there, understanding that the graph itself is now going to be a useful tool in which you can actually find the actual estimate median and upper and lower quartiles from this group data. Because obviously, if it's group data, we don't know what the actual numbers were between 11 and 20. We just know that there were 11 of them.
Yes.
So to get the actual median, well, just with that, we can't.
Yes.
So the value...
So it would be a really bad example if you had listed all of their ages as well.
The point of group data is that you're probably sitting with an enormous amount of numbers. You're not going to to list everybody's age is not practical.
No, it isn't.
So therefore, the value of the group data.
So we're moving on to the next slide.
Okay, so obviously once they've got all their coordinates, it's a case of plotting it. Okay, and typically your OGAV graph takes an S-shaped bend.
Yes.
Okay, and the more points you have, the more pronounced that S shape will become. And
do you talk about why it has that shape? You personally?
No. No.
Do you think it's valuable to talk about?
I'm sure it'd be worth getting the kids to investigate it. To go and do a bit of research on it as to why.
That's a really nice...
As to
why must the teacher supply all of the knowledge?
Yeah. Go and understand as to why exactly it does take that shape.
Yeah.
Yeah.
Good challenge activity.
There we go.
Carry on with your picture.
And they must just make sure that when they're sketching it, their vertical axis is always the cumulative frequency axis.
Okay.
And the horizontal is whatever the study is on. So in this case, the ages. Their graph, they don't join the points with a ruler. It's not with straight lines.
Yes.
So it is a curve. It's not a broken line graph.
Yes.
Okay. So that would be the...
And I see your first point is on 10 and 0.
That's the grounding point. So that's the point at which it started at. And it does have to have a grounding point on the x-axis.
Okay. Are you ready to go to the next slide? Okay. So we're going to look at this over here where we've got the median and Q1 and Q3 and...
Okay. So once they've drawn the curve... They can now from here, if the question now said give the estimate median, okay, so they would look at their vertical axis, the cumulative frequency axis, and they would say, so we've got values from 0 to, I think it was 77, if I'm not mistaken.
Yes, it was 77.
So 0 to 77. They would then say, okay, to find the median, the halfway mark, we can apply the formula a half multiplied by n plus 1.
Yes.
Okay, that formula over there. So in this case, a half multiplied by 77 plus 1, which is going to get me to, 39?
Yes.
Okay. And we would plot 39 on your vertical axis.
And use a ruler to draw across.
And what you then just need to do is go straight across till the point that you actually meet the curve, and the line straight down. And it's an estimate, okay, so there is a little bit of leeway in terms of the accuracy of the answer, but obviously I've said to the kids, it's not ridiculous. You've got one or two values above or below, but other than that, you've got to be careful. So in this case, their estimate was, I think it is 38. Sorry, it's not very clear. As the estimate's median.
Now, just a question. They've all drawn these. They're individual cumulative frequency graphs.
Mm-hmm.
How are you sure that they all look the same?
This is the challenge that you have. You're either going to give them the graph, paper as such, because
Okay.
and
With your axes set out.
with your axes set out, the increments in which they go up in are obviously then going to affect the. This has gone up in 10s. If it had gone up in 5s, the graph is going to be bigger, but you have a
Yes.
chance of it getting an answer that's a bit more accurate.
Yes.
If you had a graph that was going up in 20s, so now you're spreading those jumps out, your answer is going to be less accurate. So they've got to, it's a case of looking at the spread of their data. They had from 0 to 77. They've got to realistically plot it on a graph. They're definitely not going to be able to do it in units.
Yes.
2's still...
Can you imagine?
Yeah, exactly.
I don't know.
2's ridiculous. If they started saying 5s, I would say maybe it's plausible. It's probably still going to be quite a large graph depending on what they, if they have the space for that. But I think it would be realistic that going up in 10s would be the best option there. So I think, I would say either in an exam we need to maybe just state that they need to go up in intervals of 10. In fact, the fact that the class intervals were actually in groups of 10 as well
would make sense.
would make sense that it's going
So
up
you
in
would
10s.
supply them with the graph paper, but they would still need to put in their own axes and...
They can draw their own graph. I mean, it's possible. But I have found that, if you're trying to interpret information off that, I think at this stage they're not good enough at it yet to maybe be left to their own devices and the time factor. So I would definitely say it's worth your while as a teacher to just include a grid on your exam paper that they would need to work off. It allows for your marking to be easier and just for a bit more consistency in the answers.
And this is a paper 2.
Yes.
Now I know in matric they get right on papers for paper 2.
Yeah, they do.
So you might as well practice that skill now
absolutely.
in grade 11.
Yes.
Yeah.
So I would definitely say it's worthwhile giving them the grid. Yeah. And then from here, the other bit of interpretation that can obviously be done is to work out the lower and the upper quartiles from here. Similar method, just working out a quarter multiplied by n plus 1, and it'll give you the position of your Q1.
Yes.
And 3 quarters multiplied by n plus 1 will give you the position of Q3.
Yes. I like the fact that you use a quarter, a half, and 3 quarters to do the multiplication because it emphasizes again that you're working... Somehow they don't make that comparison. Quartiles means quarters.
Yes. And it's just to remember that little formula is giving you the position of where the Q1, Q2, and Q3 are.
Yes.
It's not necessarily the Q1 or Q2, so they mustn't make that mistake.
Yes.
Yeah.
Shall we go on to the second pressure point?
Yes.
Okay, and now we are looking at variance and standard deviation. Standard deviation is a measure of how spread out numbers. It is the square root of the variance. Yes.
So my best description of standard deviation is it's really the average deviation from the average.
Yes.
If that's so, when I teach it, that's the definition that I like to use for it. Once I understand that, then we can look at all the concepts of it being a square root to the variance and what have you. But as long as I understand that what standard deviation essentially is that average deviation from the mean.
I must tell you a funny story here quickly. I forget what class it was, but it was a grade 11 class, and we were talking about standard deviation and variance, and they weren't getting it and what it meant. So I took my whiteboard marker, and on the floor I drew a dot, and I said, okay, imagine that is the average if we're throwing paper. Then your standard deviation would be the circle around it where all of the paper landed. So your average point where it's all landed is in the middle, but paper lands everywhere around it. The funny part of the story was, for some reason, whiteboard marker doesn't come off linoleum floors.
No.
And then, of course, teaching teenage boys, they walk in and they look at this. Ma'am, why do you have a big boob on your floor?
Oh, gosh, and what can you say? It's a good introduction to just reinforce standard deviation.
Dylan's giving it.
You're having a day, aren't you?
Now I'm blushing. Okay, carry
But
on.
actually, I would... sorry, now I sound really boring. I use standard deviation all the time in my own mark sheets.
It makes a lot of sense.
And what I like to do with all my pupils is I work out standard deviation amongst their own marks.
Yes.
And then I like to work out the standard deviation in terms of the class average.
I hope you use Excel or something similar to do it. Okay.
Excel does it very well, but we're not gonna do it.
No.
But yeah, so basically, I just like to know that in amongst all the assessments that they've done in a year, and to look at the individual standard deviation, are they kind of keeping it quite close to the average, or are they all over? Is their standard deviation quite high? In which case, there's too much variance in how they're performing in their tests. So. Yeah, so there's a practical way of applying the standard deviation.
It would be quite interesting, actually, to monitor marks like that.
It is interesting. And yeah, bless Excel, because I just have to put the formula in once and it just does it. It just adjusts it every time, which
wonderful.
is it's great.
But a lot of this section is about teaching them how to read the formula.
Yeah. Well, that's it, yeah. It's all very well that Excel does it for us, but the job at this stage is to teach them the formula behind what's actually happening on that spreadsheet or on that calculator. They're obviously not required to apply the formula or to do the total working out. It's got to the point now where they're never asked to do that. They are asked to calculate it on their calculators. Okay. Possibly to make some kind of comments on it.
Yes.
But from there, they won't have to actually do the calculation as such.
Shall we look at the example?
Yeah.
Okay, so we've got an example here that says a chess team consisting of 10 players scored the following points during the year, and there's a list of numbers.
Yeah.
And the first one says calculate the mean, round it off to one decimal place, blah, blah, blah.
Okay, so obviously this question's quite scaffolded. It's broken it down into the steps just so that they know what is necessary in order to work out the standard deviation.
Yes.
So obviously the mean, the average, because you're working out the deviation from the average is important. You need to know that first. So first things first, and then at the bottom there where it's got the calculation of the average, so the sum of all the totals divided by n, the number of values there were. And here we got our average of 49.3. So now that we've got that average, now what it's asking us for is variance. Okay,
yes.
So the variance is a different story.
So the next slide.
Yes.
Okay.
Okay, so for the variance, this is what they're going to have to do.
It's the second column.
It's basically, the second column is a result of the middle one. So we're looking at the middle column first of all.
Okay.
We're looking at the average deviation from the average. So I suppose it would make sense that we're going to work out the difference of everybody's individual score to the average.
Yes.
So that middle column is taking everybody's score minus the mean. Okay, and it's giving us everybody's individual score. Some of them are positive, some of them are negative. But what the learners will find is if they add all of their scores up, the difference between the mean minus the individual scores, or the sum of the individual scores minus the mean, is always going to give you 0. Okay, and that's a result of the negatives counterbalancing the positives there.
And you can have quite a rich conversation about that.
Absolutely,
at that point.
Yes, absolutely. Again, it's quite a nice investigation that the children can go on there.
Yes.
So the point of squaring the bracket in the third column is obviously to eliminate the effect of the negatives.
Yes.
So we square all the brackets. And we land up with the sum of the x minus the x bar, or the mean squared, gives us the 2,454. Okay?
Yes.
To work out the variance, which is again, remember we're working out the average deviation from the average. We're taking the total sum of the third column, and we divide it by the total number of values, which was 10. Okay?
Yes.
And that gives us 245.41. But now we can't forget that we've squared all the values. Okay?
So then we square root it.
So therefore, to get standard deviation, sorry, that wasn't where that didn't include the final thing there. But finally, the standard deviation part of the calculation would then be to square root it.
Okay.
So the standard deviation formula is just putting a big square root over the bottom formula down there. So it's the square root of the sum of your x minus
Do you
your
want
mean
to write
squared.
it up here quickly?
I can do.
And
standard deviation has a little symbol such as that, and it's the square root of the sum of our x minus x bar squared divided by n.
I think it's such a great process to watch them understand that kind of notation.
Yeah, absolutely. And you know, I think if we, as a starting point to teach it, to really break that down, you know, they'll never not understand that formula, which looks quite intimidating.
It does.
To a poor child when they've never seen that before, and to not understand where on earth all of that comes from. But yeah, just breaking it down, I think, helps incredibly, and to understand where to start.
Yes, and I think next year when they start looking at other complicated looking formula and
correlations and absolutely.
Yes, to know that it's simple. It will
certainly
help. Yes, Dylan.
Just a curiosity, because I don't know, what happens if instead of squaring the values to get rid of the negatives, you take the absolute value instead? What happens then? Do you know?
The absolute value, would you not then just go straight to the standard deviation? I would have to try it. I'd have to play with it, to be honest with you.
Okay.
But you're right, because the absolute value, because then you would bypass the squaring part of it.
But if you're square rooting the whole...
But I think it would make a difference.
Yeah.
It's interesting, and actually I think it's worth playing around with.
It may be another statistical measure that we
haven't actually
not aware of.
Yet. But there's something to that, but something I definitely think is worth just doing some work on.
Okay.
Yeah. Because the sum, now I need to play with it. But if you took the individual square root of each one of 691.69, if you took the square root of each one of them individually and summed those, it would be a different answer to the total sum of the squares square rooted.
Okay, that was a lot of words, and I've got to be honest, I stopped following you. So
I'm just following on what Dylan said, but again, I'll have to go and play around with this, and possibly everyone else.
Perhaps put it on the blog and see if anyone out there is any wiser than we are.
Yes,
you know what? It's not something. It's just a case of sitting with a calculator and a pen and just fiddling around with it. But I don't know if it would give you the right answer, but it might be a different measure. That's
a different kind of measure.
Yeah.
I don't think we do absolute value in CAPS.
In AP Maths, you do.
In AP Maths, yes, but
okay.
Yeah,
it used to be part of the syllabus, but unfortunately not all of them do it anymore. So the word absolute value might be a bit of an unknown factor to a lot of them.
Yeah. Okay, your third pressure point says distribution of data, positively skewed, negatively skewed, or symmetrical data. And this gets almost everyone.
Yeah, this is okay. So this obviously is just applying to good old box and whisker plots.
Yes.
And the fact that the children need to comment and make some kind of, sort of form some kind of understanding of what this picture actually means to, and if there's, get some kind of valuable information out of it, particularly if they're having to compare two different box and whiskers together. So, and a very, very common question. I think something that's really important that learners get their heads around, because it's very likely to come up in an exam.
Now, in some textbooks, it says skewed to the right and skewed to the left.
Yeah. I think that's just semantics. I think that's just the wording that they use. Yeah.
Somehow it just feels easier to say, okay, well, this is skewed to the right and this is skewed to the left.
Yeah. Honestly, I think it's a preference more than anything. Positively skewed is, I guess, to me, saying positively skewed holds a bit more value than just skewed to the right, because positively skewed is the mean has the data is a greater spread on the upper half of the box and whisker, and as a result, it's pulled the mean higher than the median, and as a result, there's a positive skew to it.
So when you explain it like that, it does actually
than just saying skewed to the right or skewed to the left.
Yeah, that's an easy answer for with very little understanding. I must be honest.
Yeah, so I think if you're wanting to actually get them to get a more sort of complete understanding of it, then I think using the words positively and negatively skewed is better.
Yes.
Yeah.
Well, you've brought some box and whisker plots for us to look at and comparisons of them.
Yes.
And I think that's where they get really interesting, actually.
It is. I think the first thing that's really important to teach the children is that when you're looking at a box and whisker plot, and I'm going to sort of focusing on Class A for now, the children mustn't misunderstand it. That on the in the last quarter, they mustn't think that last quarter indicates more children in the class than any part of the diagram. So the first and foremost thing with the box and whisker is to really emphasize that every single piece of the box, every quarter of the box and whisker represents 25% of the data. The spread, the reason why one 25% might be smaller or shorter than another 25% is the spread of the data. And that's what the box and whisker is doing, is it's a diagram representing the distribution or the spread of the data. So to really get a good understanding of it, a good idea would be to look at the median, look at the halfway mark.
Yes.
And from there say, okay, so looking at Class A, the example is regarding sessions, 2 different yoga classes. So Class A, the median number of attenders of that class is 6, okay? So from there, looking at the median for Class B, we've got 14. So I can immediately see that the median value is much higher in Class B. Looking at that, then I can say that, well, from the minimum point to the median, that represents 50% of the classes.
Yes.
And 50% of the classes are less than 6 people. Other 50% of the data are from 6 to 24 people. So we've got quite a large variation of attendance at that class, as opposed to Class B, who's 50% of the classes have a 10 to 14 people attendance, and the other 15 is from the other 50% is a 14 to 24 attendance. So, for example, if I was doing an assessment on the yoga instructor and I wanted to decide who was the better yoga instructor by means of the attendance in the class, I'd probably say that Class B is the better yoga instructor because it's got a much more regular attendance in terms of...
Well, that would be a valid conclusion, I think.
Yeah. If you're talking about mean, okay, let's look at mean. Class A, okay, I think we all agree, we can see it's got a much wider spread of data than Class B. Class B looks like it's much further up than the number line. So I think by just straight assumption, we would assume that the average attendance for Class B is much higher than the average attendance for Class A. But you have to then say, okay, well, hang on, let's just look at this. From the median, which is only 6, there's a much greater distribution from the median to the maximum in Class A, so the upper 50%. So the conclusion there is that that's definitely positively skewed. The average for Class A, because of that greater spread on your upper half of the data, is definitely going to be higher than the median.
Okay.
Whether it's going to be as high as Class B's, it's probably not. There's probably too much of a spread on the lower half in order for it to make up the difference. But because there is a positive skew on the upper half, the assumption there, and that's generally the kind of answer we're looking for from the children, is discuss the skewness of the classes. So Class B, I would say, is slightly positively skewed because of the upper whisker,
yes,
which is a little bit longer. But otherwise, generally speaking, it's quite symmetrical.
Yes.
Whereas Class A, there's definitely a positive skew, where your mean is going to be higher than your median.
Okay.
Even though they share the same maximum, okay, and that's something that we'd want the children to point out as common elements on the box and whiskers.
Yes.
So look for things like, do they share a common median? And that's always quite interesting, because if they share a common median, then you would assume possibly the mean would be similar, but that's when you'd look at the spread and then see what's actually, even though they share a common middle value, what actually is happening in the spread, which is shown in your diagram. So if I was asking the children to comment on that kind of thing, I would ask them to comment on the skewness, comment on which one would possibly have the higher average of the mean attendance, and then I suppose, which yoga instructor would be the better one, that kind of thing, and that's giving it a bit of a practical element.
Okay.
Yeah.
Well, shall we look at your next one?
We can do.
Okay. And we've got algebra scores for Class 1 and Class 2.
Okay, so these ones are probably a bit more similar if we look at it. So let's start with looking at the median, okay? Class 1, we've got a median score of 80%. So half of the class are getting less than 80%, and half of the class, 50% of the class, are getting from 80 to 90%. So because there's a greater spread of data on the lower half of the class, there's more spread from what is it? Looks like 55 to 80.
Yes.
It's going to cause the average of class 1 to definitely be lower than the median. So the average.
So if a teacher wanted to say that my class is doing better, then they wouldn't talk about their mean. They would talk about their median in this case.
Well, I mean, that's not going to. If they hopefully they were talking to people who wouldn't know the difference.
Yes.
Yeah. So the median is just your middle value. It gives you a sort of a marker as to where the 50% value is, and then from there to look at that mean in comparison to the halfway mark.
Yeah.
As well as the quarter mark and the 3/4 mark.
Yeah.
For class 2, okay, so we've got a higher total. The maximum amount is actually higher than class 1. The median value for class 2, okay, so the median value is lower. It's about 75. This one's quite an interesting one because what I would say is this: we've got quite a large spread on your first 25%. So you've got a 50 to 70, so that's quite a large spread. Then from 70 to 75, which is up to the 50%, that's quite small. So looking at that first 25%, you'd almost be inclined to want to say that there's a bit of a pull down on your data. But then you look on the upper half and you say, okay, hang on. We've got from 75% to 90, which is my upper quartile.
Yes.
And then from 90 to 100, which is then up to the maximum. Which now things hang up, but actually that then looks like there's a positive skew to it.
Yes.
So I would almost say that the two sides actually counterbalance each other here. You've got quite a large spread of data on the first 25%. And then the third 25% is also another quite large spread. The other two, the second 25 and the fourth 25, sort of are the ones that cause it to be to balance out. So although I'd probably make this assumption, I would say that there probably is a slight positive skew to this. And I would say that because if I look at the spread of my look at my upper quartile,
yes,
and so from my median to my Q3, that's from 75 to 90, and then from 90 to 100. So we've got, what have we got there? 25%. We've got a 25%
from your
spread
median
from the median to the 100%.
Yeah.
Whereas here we've got 50 to 75, so it's also 25%. So this one over here, I would say there's probably a very, very slight difference between your mean and your median.
You can actually have quite a few conversations about this one.
And you know, it is open to interpretation. I don't have actual numbers here to work off, so I'm simply making my interpretation of it. But I wouldn't be surprised, let's say, if I found that the average was probably, say, 78 and the median is 75.
Yes. I think that would make sense.
I think that would probably be what would end up being. And in comparison, class 1, whose median is 80, because of that lower spread, it would probably also pull the average down to probably about, I would actually say it would probably pull it down maybe a bit lower than 78. So just purely on what I'm looking at here, I would possibly put my head on the block and say class 2 did better in terms of an average.
You'd possibly put your head on the block, but you're not quite sure.
But I would justify it.
Yes.
So, and with justification, I would say that's why.
Yeah. Well, Tamlin, we have come to the end of our time.
We have.
Yes.
Sure, that went quickly.
It does. Thank you for joining us.
It's a pleasure. Thank you for having me.
And remember that if you want to win a phone or a tablet, you need to send us your teaching resource or teaching idea. And it could be about stats. It could be about something else completely different. Send it to competitions@digitalclassroom.co.za. We will check them out and we will let you know if you are a winner. Thank you, Dylan, for your button pushing. And join us again next week. Goodbye.